Alright, 6.4, the triangle midsegment theorem. Essential question, how are the midsegments of a triangle related to the sides of a triangle? Core vocabulary is midsegment of a triangle, midpoint, parallel, slope, coordinate proof. What you're expected to learn is to use midsegments of a triangle in the coordinate plane and to use the triangle midsegment theorem to find distances. Okay. Midsegment of a triangle is a segment that connects the midpoints of two sides of the triangle, and every triangle has three midsegments, and that's going to form what's called a midsegment triangle. Okay, so let me show you what I mean. I have a triangle ABC, and I want to create what's called a midsegment, and what that is I have to take the midpoints of all three sides. So let's go ahead and say AB. If I find the midpoint here, and I call this M. Because it's the midpoint, that means the segment from A to M and the segment from B to M are congruent. Then I do the same thing with this side over here, BC. Let's say that I call that N. Okay, that means that this side here is going to be congruent to this side over there. But the actual mid-segment is the segment that connects M to N. Okay, and then since I have three sides, that means I have one more midpoint connecting or between A and C. So let's just put that there, call that P. Again, that means that this piece AP and is congruent to segment CP. Right? But the thing is that I can connect M to P. There's my second midsegment. My third midsegment would connect M to P. Okay, so MN, NP, and MP are my midsegments, and my triangle MNP would be the midsegment triangle. Okay, so here's the first example. It says vertices of a triangle are A, -5, 6, B, 3, 8, and C, 1, -4. What are the vertices of the midsegment triangle? All right, and based on our definition, what we have to do to find these vertices is we have to take each side and we have to find the midpoint. So my first segment I'm looking at, I need to make kind of a list for myself so I can keep this straight in my head. AB, then it's BC, and then I need the midpoint of AC. Okay, so I'm going to have to do the midpoint formula 3 different times. And so looking at it first, I'm going to have -5 plus 3 divided by 2. Then I want to get 6 plus 8 divided by 2 for my y value. -5 plus 3 is going to give me -2 over 2, and this is going to be 14 over 2. So the midpoint of AB is going to be -1, 7. Alright, which is going to be right here. Alright, so, and we can call that C. And so C is at -1, 7. And the next midpoint that I'm going to do is BC. So I'm looking at these 2 points, the 3 and the 8, 1, -4. So I need to do 3 plus 1 over 2, and then 8 plus -4 over 2. And I want to simplify that. 3 plus 1 is 4, so that comes out to 4 over 2. And then this is going to be 8 plus -4 is going to be 4 over 2, which would simplify to 2 over 2. So this midpoint is going to be 2, 2, which would be about right there. We can call it D. So let's say D is at 2, 2. And the third one, using the points A and C, we want to do the midpoint formula again. So I'm looking at -5 plus 1 over 2. Then I need to look at my y values, so 6 and -4. I'm going to put that over 2. -5 plus 1 is going to give me a -4 over 2. 6 plus -4 is going to give me a 2 over 2. When I reduce that, I get, or simplify, it's going to be -2, 1. And this other point here, we can call this E. Right there. And so the third midpoint, or the third vertice, is going to be at -2, 1. Okay? And so those are the vertices of the midsegment. If I were to connect these here, Okay, that would be my mid-segment triangle. These are the vertices that they asked me for. One other thing that we didn't mention before is that each of these mid-segments, so like CD, is going to be parallel to AC, segment AC. Segment DE would be parallel to segment AB. And then segment EC would be parallel to BC. And you can check that by looking at the slopes. In triangle JKL, show that midsegment MN is parallel to segment JL and the distance from M to N is equal to half the distance from J to L. Next we got the triangle midsegment theorem, and that simply says that a segment connecting the midpoints of two sides of a triangle is parallel to the third side and is half as long as that side. So I know D and E are midpoints based on the diagram, because if AD is congruent to BD, that means D has to be a midpoint. Same thing with E. I know CE is congruent to BE, so E has to be the midpoint of the segment BC. And now if I connect these two midpoints, two things happen. One of them is that this segment here is parallel to this segment there. And whatever the length of AC is, DE, segment DE is half of that. So let's say that AC happened to be 14 units long, then I would know that DE, segment DE, is going to be half of 14, which would be 7. Okay, that would be an example of midsegment theorem. Alright, so looking at an example, segment DE is a midsegment of triangle ABC. You want the value of x. Well, this should be easy because DE, the distance from D to E, is equal to half the distance of the length of BC. And since BC is 28, I want half of that, and half of 28 is 14. Alright, so the distance from D to E would be 14 units. This next problem, segment DE is still a midsegment of triangle ABC. We want to find the value of x, only this time they gave me the value of the midsegment. So I'm kind of going backwards on this. I know that DE is still half of BC. Okay, but this time, the known part is 15, that's this midsegment part, is half of BC, or half of x. Do it that way. Okay, and so I want to go backwards, which means I'm going to, technically I could divide by 1/2. Okay, you do it that way. Or the same thing, what ends up being the same is I could actually multiply by 2 on both sides, because 2 over 1 times 1/2 would just be 1, that would just be x, and 2 times 15 would be 30. So in this case, the length of BC, or x, is 30 units. Alright, another way that you're going to use the midsegment theorem is, if you notice that this diagram, the values and things are on the side. Alright, you do know that it's a midsegment, and the thing is that you need to know is how are these points right here, D and E, made. Since it's a midsegment, that means E is the midpoint of AC, and since it's the midpoint, I know that CE and AE, those two lengths are equal. So if AE is 9 units, that means CE, which in this case is our x, is also 9 units. Okay? Because it's a midsegment. And the midsegment is made by the midpoints. Okay? So in this case, x is 9. Alright, what is the perimeter of triangle DEF? Alright, in the diagram, segment DE is a midsegment of triangle ABC, and segment FG is a midsegment of triangle ADE. I want you to find the distance from F to G. Alright, in this example we got a word problem. So the diagram below shows a triangle woodshed. You want to install a shelf that's halfway up the 8-foot wall, and that will be built between the two walls. So I want this dotted line here. This is my 8-foot wall, and so since it's halfway, that means I'm using the mid-segment theorem, and I know that that segment is going to be half of 15, okay, which happens to be 7.5 feet. Alright, part B of this problem says, how many feet should you measure from the ground along the slanting wall to attach the opposite end of the shelf so that it will be level? Alright, because I'm going halfway up the 8-foot wall, I know that this right here is a mid-segment of this one, which means it has to be parallel. And since the way this diagram is drawn, I know that these two lines here are perpendicular, so this height right here is going to have to be 4 feet, which tells me it's a mid-segment, which means that these 2 points right here where it's connecting are midpoints. So if I want this length up here along this slanted wall, because this is a midpoint, it's going to be equal to half of 17 feet, and half of 17 feet is going to be 8.5 feet. Okay. So I know I have to measure 8.5 feet up from that slanted wall.